So in this video, we're going to see a couple of different solutions that we can get when we're solving these three variable systems. So my first step here is I want to go ahead and eliminate a variable. It doesn't matter which one you choose to eliminate. I'm going to go ahead and choose to eliminate my x's. Since that first x doesn't have or has a coefficient of 1. You could have done y, you could have done z because of this first equation, but I'm going to go ahead and choose x. So I'm going to work with equations 1 and 2 first. So when I rewrite those, I have x plus y plus z is equal to 2. And so to eliminate x, I need to multiply this first equation by -5. And so when I do that, I get -5x minus 5y minus 5z is equal to -10. And then I have 5x plus 5y plus 5z is equal to 3. Now I see something different happens when I add these. I see that all of my variables actually end up canceling. And so I'm left with just a 0 on the left-hand side. But on the right-hand side, when I add -10 and 3, I get -7. And so I have the statement 0 equals -7, which is not true. And so since I end up with a statement that's not true, the answer for this system is going to be no solution, just like what we saw when we were solving two variable systems. Okay, let's look at one more. So here I have x minus y plus z equals -3, x minus y minus z equals -3, and 5x minus 5y plus z is equal to -15. So my first step is I want to eliminate a variable. I want to go ahead and eliminate my z, just because they're actually already set up to be eliminated without having to do any manipulation of my equations. So I'm going to first take equations 1 and 2 and rewrite those. And so I see that my z's already cancel out, and I get 2x minus 2y is equal to -6. And now I'm going to go ahead and rewrite equations 2 and 3. And I choose 2 and 3 because my z's already have opposite coefficients. And so I see that my z's cancel again here because -z plus z equals 0. X plus 5x, I get 6x. -y minus 5y, I get -6y is equal to -18. So I eliminated the variable, so now I have a two-variable system. And so now I can rewrite, or I can solve this new system. And so I have 2x minus 2y equals -6. 6x minus 6y is equal to -18. And here I'm going to go ahead and eliminate x. So that means I need to multiply my top equation by -3 so I can get a -6x, because I want my x to have the same coefficient with opposite sign. So when I do that, I get -6x plus 6y is equal to 18. And then I have 6x minus 6y is equal to -18. And so now I see something different happens when I solve this. I see my x's cancel because -6x plus 6x is 0. My y's cancel, and so I end up with a 0 here. And then 18 minus 18 is also 0. So here I end up getting a true statement. 0 does in fact equal 0. So since I get that true statement, this is going to be infinitely many solutions, just like what we saw when we were solving linear systems.